This is the code in action video for Chapter 8. In the first code example of Chapter 8, we implemented the input handling hook from the React hooked up library to simplify input handling in our blog application. So as we can see, the input fields, they still work the same way as before. We can log in, we can enter text, everything works just the same way. However, if we take a look at the code, we're not using a state hook anymore to save the input field state, but we're using the use input hook from React hooked up. So the input handling hook returns a value and a bind to input object, and the bind to input object contains an onChange handler function, which we can use by using spread syntax on the input field as follows. The value is used the same way as with a state hook. As you can see, this greatly simplifies input handling with hooks, and we don't need to define our own handler functions for all input fields anymore. In the second code example of Chapter 8, we implemented various community hooks in a small example project. We're now going to take a look at each of them. First of all, we have to open the DevTools so we can see the console. And the first hook that we're going to take a look at is the use onMount hook, which triggers onMount. So this directly replaces the React lifecycle methods. So as you can see, we can unmount the component. When we mount it again, it will print mounted in our console. We can also do the same with an effect hook. So this has the same effect. It just, when a component mounts, it will print mounted with effect. So this is an effect hook with an empty dependency array. Then there's also a use on unmount hook, which triggers when we unmount the component. And we can also do the same with a cleanup function and an effect hook, as you can see here. Then the library also provides use lifecycle hooks hook, which combines the unmount and onMount hooks. And as you can see, unmounting gives an effect and mounting also gives an output here. Obviously, we can also separately define those two hooks, which has the same effect. And we can use an effect hook with an empty array as dependencies and a cleanup function to replicate the lifecycle hook behavior of unmounting and mounting. Next, we are going to take a look at the merge state problem. The merge state problem happens when we think that the React state hook works the same way as this.setState in React class component, which it does not. We can see here that we have a count and a +1 button, and when we press the +1 button, the count gets increased, but the button suddenly gets disabled. So what happened here? Let's take a look at the code. So as we can see here, we are defining a loaded boolean and a counter value, and then on click on the button, we increase the counter value by 1. We also disable the button if the loaded state is false or not defined. So what happens here is that the state hook actually just replaces the state value with this object. It does not merge the current object with the new object like this.setState does in React class components. So what happens is when we click the button, it increases the counter state by 1, but it also overrides the existing object, so the loaded true gets discarded. We do not have a loaded key anymore in our state object, which means that the button gets disabled when we increase the count. To solve this problem, we would have to merge state using the spread syntax like here. So if we use the spread syntax with a state hook, we are going to first of all get the loaded value and the counter value from the existing state, and then we set the counter value +1. This solves the problem. So as we can see here, we can press +1, +1, +1, and it just works fine. The loaded value does not get overwritten anymore. There's also another hook that we can use. We can use the useMergeState hook from the React hookup library, which has the same behavior as this .setState from React class components. So here we can use setState as before. We just pass the key that we want to update, and this hook will automatically merge the existing object with the updated object, so the bug does not happen there. As we can see, we can press +1 and it works fine. In the third code example of chapter 8, we took a look at a couple other community hooks that have nothing to do with replacing React class component functionality directly, but with implementing various other features with hooks. So the first hook is the usePrevious hook, and the usePrevious hook, it will just store the previous value as well as the current value of anything. So we can use the value of an existing state hook, we can use the value of props, and it will always store the previous value and the current value. So as we can see, value was 0 and is now 1, and so on. The next hook is the useInterval hook, which allows us to use setInterval with hooks. The advantage of doing that versus just defining a setInterval is that when we use interval, even when the component re-renders, the interval will persist properly. So as we can see, the seconds just keep counting up because the interval triggers each second. We can also implement the same with an effect hook, but then we have to do the cleanup ourselves, define our own cleanup function, which is a bit more tedious. There's also the same goes for the timeout, so we can replace setTimeout with useTimeout, which greatly simplifies dealing with timeouts in React components. And the timeout here just waits a couple seconds and then it says ready, so it works fine. The next hook is the useOnlineStatus hook. This actually shows us if we are online or not. The onlineSync hook here, this shows us actually when we go online again. So we can take a look at how this works by turning off the Wi-Fi first. So now it shows you're offline, and this one also shows you're offline. And if we connect again, we're going to see that this will show you are online again, and the online sync will actually trigger an alert. So yeah, now the alert got triggered. The next hook is the useBoolean hook, which simplifies dealing with the data structure of a simple Boolean. So we have a toggle function which we can bind to the button, and then we can toggle it on or off. The next hook is the useArray hook, which simplifies dealing with arrays. So it offers us features to functions to add elements, remove elements by index, or clear all elements from the array. The next hook is the useCounter hook. Here we can define a minimum value, a maximum value, and a step. So how many points we want to increase per increment or by decrement. So here we have 1, 2, and 3, and then we have the maximum value of 3, so it rolls back over to 0. This can also be configured so that it stops at 3 or stops at the minimum value, or it wraps over the minimum value. So this is quite useful for counters. The next hook is very useful. It's called useFocus, and it can be used to deal with input events on focusing an input field or any kind of element. So as we can see here, the element is not focused right now, but if we click into it, it's focused. So we can trigger some kind of action when the element gets focused. And the last hook is the useHover hook, and it does the same as the focus hook, but when hovering the element. So as you can see here, when hovering over the element, it just triggers an effect and the text changes. In the fourth code example of chapter 8, we took a look at the responsive design hooks. So we actually used a hook to get the current size of the window and then dynamically hit or rendered components. The advantage of using a hook for this instead of just using CSS is that not just the element gets hidden, but also that the element will actually be gone from the React tree. So we don't have to In the fourth code example of Chapter 8, we implemented responsive design using hooks. The reason why we should use a hook instead of simply using CSS to implement responsive design is when we want to actually not just hide components via CSS, but when we want to not render certain components or trigger certain effects when the screen size is below a certain value or above a certain value. So in this case, we hid all these elements on the mobile screen, and we can show this by making the window smaller, and then when it's small enough, it will just hide these components. And then once we increase the size again, we can see that the components actually re-render because the themes make another request. The change theme component makes another request, and it shows loading themes for a second. In the fifth code example of Chapter 8, we implemented undo-redo functionality into our create post component using the use-undo hook. So the use-undo hook makes implementing undo-redo functionality really simple. As you can see, if we log in here, we can now enter some text into the create post component. And we now have two additional buttons here, one for undo and one for redo. So now let's write some text here and some more. And now we can see undo. We can use undo and we'll stepwise undo some of the text until nothing is entered anymore. And then we can also redo. So if we make a mistake, we can undo and then some other text. And then we can create our post.